prepare for an exciting event in the world of space exploration. SpaceX, in collaboration with the U.S. Space Force, is gearing up to launch the Boeing-designed X-37B spaceplane on its 8th mission. This launch is set to take place just before midnight on Thursday, specifically at 11:50 p.m. EDT or 3:50 UTC from the historic Pad 39A at NASA's Kennedy Space Center. The mission is officially designated as USSF-36 and Orbital Test Vehicle 8, OTV-8. The X-37B will be under the operational control of the Fifth Space Operations Squadron, which is part of USSF Delta IX, and will work alongside the U.S. Air Force Rapid Capabilities Office, USAF RCO. For those eager to follow the launch, Spaceflight Now will provide live coverage starting about an hour before liftoff, ensuring you don't miss a moment of this thrilling event. As for the weather, the 45th Weather Squadron has predicted a 65% chance of favorable conditions for the launch window on Thursday night, with the likelihood of good weather improving to 80% as the window progresses. Meteorologists are closely monitoring Hurricane Erin, which is currently moving along the east coast of the United States. They noted, "The very large Hurricane Erin will continue moving north and eventually northeast off the eastern coast of the U.S. and out into the open Atlantic through the remainder of the week. This storm could influence weather patterns, leading to increased moisture and storm activity in the area, particularly on the east side of Florida, including the spaceport. The Falcon 9 rocket will utilize its first stage booster, designated B-1092, which is set to make its 6th flight. This booster has previously supported missions such as CRS-32, GPS-37SV-08, and NROL-69. Approximately 8.5 minutes after liftoff, B-1092 will attempt to land at Landing Zone 2, LZ-2, at Cape Canaveral Space Force Station. If successful, this will mark the 13th successful landing at LZ-2 and the 490th booster landing overall, a significant milestone in reusable rocket technology. The X-37B was encapsulated within the Falcon payload fairing on August 14 and subsequently transported to Launch Complex 39A for integration with the Falcon 9 rocket. The complete rocket assembly was rolled out to the launch pad on Wednesday morning, ready for this historic mission. Notably, this will be the 3rd time a Falcon rocket has launched one of these spaceplanes, following previous missions OTV-5 and OTV-7, which were launched using the Falcon 9 and Falcon Heavy rockets, respectively. The more powerful Falcon Heavy was necessary for the last X-37B mission to achieve a highly elliptical, high Earth orbit. The OTV-8 mission follows a series of 7 previous flights that collectively spent an impressive 4,208 days in orbit. The longest of these missions, OTD-6, lasted nearly 909 days, showcasing the capabilities of the X-37B. Michelle Parker, Vice President of Boeing Space Mission Systems, highlighted that the company has made significant improvements to its 2 reusable X-37B spaceplanes since their inaugural flight in 2010. The first of these 2 spaceplanes will be the one flying the OTV-8 mission. Throughout our missions, we've utilized several generations of batteries and solar cells that have greatly enhanced our power generation capabilities, Parker explained. We've also improved the thermal protection tiles to boost their maximum temperature tolerance, manufacturability, and reusability. The previous mission, OTV-7, introduced advancements in fault protection, autonomy, and collision avoidance, which are becoming increasingly vital as space becomes more crowded. This time, the Space Force is emphasizing 2 key areas: communications and navigational precision. One of the highlights of this mission will be a laser communications experiment, which is expected to significantly enhance the U.S. Space Force's ability to utilize proliferated space networks as part of a more diverse and resilient space architecture. General Chance Saltzman, the Chief of Space Operations for the U.S. Space Force, stated, "In doing so, it will bolster the resilience, reliability, adaptability, and data transport speeds of our satellite communications framework." Additionally, the OTV-8 flight will showcase what the Space Force describes as the world's highest-performing quantum inertial sensor ever used in space. This innovative technology will allow for navigational capabilities without relying on GPS, instead detecting the rotation and acceleration of atoms. Colonel Ramsey Horn, commander of Space Delta 9, remarked, "The quantum inertial sensor demonstration on OTV-8 is a significant advancement for operational resilience in space. Whether navigating beyond Earth-based orbits in cislunar space or functioning in GPS-denied environments, quantum inertial sensing provides robust navigation capabilities when GPS is unavailable." As for how long the X-37B will remain in orbit this time, that remains uncertain. Interestingly, only one of its previous missions, OTV-1, lasted less than a year. It launched from Florida in April 2010 and landed in California in December of the same year. So what do you think about the advancements being made in space technology? Are you excited about the potential of quantum sensors and laser communications? Share your thoughts in the comments below.